This is example 6 in section 3.4, equations and graphs of polynomial functions. We're going to write the equation of a polynomial function that matches the graph that's given. The most important points on this graph are the x-intercepts. From the x-intercepts, we can write the factors, and then we can look at the multiplicity at those zeros. So at x equals -3, the factor would be x plus 3. The multiplicity at this x-intercept would be 1. The graph approaches the x-intercept and continues, so there's a y value sign change. The other x-intercept is at 1. The factor for this would be x minus 1, and the multiplicity would be 2 because the graph approaches the x-intercept and then bounces and goes into the positive direction. So there's no y value sign change. So what we have is we have the two factors, x plus 3 and x minus 1. We know that the multiplicity of 1 would be a 1 exponent. The multiplicity of 2 would be a 2 exponent. What we don't know is this value a, the coefficient. We want to know how wide or how narrow this function is. So we're going to choose a point on the graph to be able to help us solve for a. Now you can use several points. You could use the y-intercept. You could use 2, 5, any point that's precise on the graph. So if I use 0, 3, I am choosing a value for x and y. And I'm going to sub that into my function to solve for a. So y has a value of 3, a is unknown, x is 0. This x value is 0, but don't forget you have an exponent 2. And now we're going to solve. So we have 3, -1 squared would be 1. When you multiply, you have 3a. We're going to isolate a by dividing by 3, and a happens to be 1. So my final answer is 1, x plus 3, and x minus 1 squared.